Hello students, let me explain use of Newton's second law to determine acceleration in some practical cases. Okay, so we use the Newton's second law to determine acceleration in some practical cases. First case, we have a block, okay, of mass m which is placed on a plane. Now force is applied horizontally. First is the example of pulling. So we have a horizontal block which is placed on a plane, and the force is acting horizontally, the force is applied horizontally. So there are two cases possible. One is pulling, another is pushing. So this is example of pushing. Okay, so now we know that weight, the two forces acting on this block, one is weight which is equal to mg, and another force is normal reaction force. Okay, normal reaction force exerted by this plane on this block. So weight is acting on this, weight is the force exerted by this block on the plane, and the reaction force is the force exerted by this plane on the block. So net force is r minus mg equals to 0. Okay, this weight balances this normal reaction force. Okay, or normal reaction force balances the weight, so net force is r minus mg equals to 0. As a result, we can write r is the reaction force, r equals to mg. Okay, understood. Let's say F is the force which is acting on this block horizontally towards this direction, horizontally. Then let's say A is the acceleration of this block towards this direction. Then from the Newton's second law, we can measure F equals to ma, and from there we can write A equals to F by m. Understood. So here in this simple case, we can easily find the acceleration by finding force and mass. Understood. So force is the force acting towards this direction horizontally. This is the example of pulling. It can be pushing also. For both cases, the r minus mg equals to 0. These two forces are equal and opposite, therefore r equals to mg. The reaction force becomes equal to mg, and if this force makes this body accelerate by acceleration a, then we can write using the second law F equals to ma, where m is the mass of this block, and we can easily find the acceleration of this block, which is equal to F by m.